All right, 7.4 properties of special parallelograms. So we have rectangles, rhombuses, and squares. Okay, these are still parallelograms. They still have all the properties of a parallelogram, but they also have their own, and we're gonna write them all on a little Venn diagram, so hopefully it clarifies everything. All right, looking at these, rectangle, okay, a parallelogram with 4 right angles. So that's something that you have to know. I feel like rectangle and square are easy ones. Rhombus, is also easy, but I feel like we know what a rectangle looks like. We know what a square looks like. It's like they're all right angles, so hopefully it's pretty easy for those. Rhombus has 4 congruent sides. Okay, rectangle, 4 right angles, rhombus, 4 congruent sides. And then a square has the properties of both a rhombus and a rectangle. So it's a right angle and 4 congruent sides. All right, corollaries, we have a rhombus corollary. A quadrilateral is a rhombus if and only if it has 4 congruent sides. Keep in mind, if and only if, I could switch the order. Okay, it's biconditional. I could put it in any order. So yes, if it has 4 congruent sides, if and only if, a quadrilateral is a rhombus if and only if it has 4 congruent sides. So 4 congruent sides. Then my rectangle is a quadrilateral if and only if it has 4 right angles. Has to do with my angles. And then a square, if and only if it is a rhombus and a rectangle. So meaning it's 90 degrees, okay, all right angles, and all sides are congruent. All right, this is my Venn diagram. We have seen these. We have hopefully worked with these just so we understand what goes with what, okay? These are, again, all quadrilaterals. And then you can see my rhombus, square, rectangle are within my parallelogram, so they still have the properties of parallelograms. And again, just definition of parallelograms so we know it. Opposite sides are parallel. That applies to everything. Okay, it applies to everything. So let's go ahead and write the properties of a parallelogram so we have them. There are 4 that make up my parallelogram, so I'm going to write them here so we know them. The first one, we know opposite sides are congruent. The second one, we also know opposite angles are also congruent. And then there are 2 more. I'm going to write them on the other side just so I have some more space. So here's 3. This is consecutive. Angles are what? Good. Okay, the consecutive angles add to equal 180. And then my last one, what do the diagonals do?
Intersect.
Yes, they do, but what do they intersect? How do they intersect? They bisect. Your diagonals bisect each other. Okay, so yes, do all 4 of these properties apply to rhombus, square, rectangle? Yes, they do. But then, like I said, they also have their own. So let's go ahead and look at rhombus. We're going to go ahead and write the rules for that one. What applies specifically only for a rhombus? There are 2. The first one, diagonals are perpendicular, which means they're 90 degrees. So drawing it for you, here are my diagonals. It's going to be 90 degrees. Same thing with this one, just drawing the second example. These are 90 degrees. Okay, so that's the first thing we have to know for rhombus. Yes, 4 congruent sides, which is true. And diagonals are 90 degrees, as well as the second one Your diagonals bisect the opposite angles. Diagonals bisect the opposite angles, okay? So what does that mean? If I'm looking at this diagram, if I'm looking at these two diagrams, your diagonals bisect each other. So these are congruent. These are congruent. Same thing here. Okay, same thing with this one. They're bisecting each other. Okay, so make sure you understand that they are bisecting each other and the opposite angles. All right, I'm going to go ahead and go to my rectangles. I'm going to go to squares after. Go to rectangles. What do I know about my rectangles? Yes, 4 right angles. So if you want to draw your little right angles, go ahead and draw all 4 right angles. You have right angles in your rectangle. And your diagonals are congruent. Diagonals, they're congruent. So drawing my diagonals. They're all congruent to each other. Same thing with this one. They're all congruent. Okay. Again, these still have the properties for quadrilaterals, but again, they also have their own specific ones. So now when I'm looking at square, if you look at the Venn diagram, they overlap rectangles and rhombuses. So when I'm looking at my square, what is my properties for square? All properties Okay, all properties of your parallelogram, your rhombus, and rectangles. Okay, they all apply for squares. So when you're looking at this diagram, we should kind of have an idea of what goes with what. So kind of drawing a, I don't know what you would want to call this, like I guess a chart. Quadrilateral makes up all of them. Okay, all of these are considered quadrilaterals. Then I have my parallelograms. And then things that fall under parallelograms, they're separate, they have their own. Rectangle, rhombus, and then squares have all of them. So just for you to see what falls under what category, all of these have the properties of a quadrilateral. Okay, they're all considered quadrilaterals. Parallelogram has its own properties, which are included for rectangles and rhombuses. And then rectangles have their own properties, as well as rhombuses also have their own properties. But squares has all of them. Okay, so just so you can see it and understand what goes with what, this is what makes up my special quadrilaterals. All right, theorems, yes, we are still going to have proofs. We're going to have proofs on our tests. We have rhombus diagonals theorem. Again, guys, it's in the vocabulary. These are not hard, but you have to remember them. Yes, so please do not wait to study. Rhombus diagonal theorem. What do I know? Diagonals are perpendicular for rhombus. Okay, my diagonals are perpendicular for my rhombus. Rhombus opposite angles theorem. Opposite angles bisect, okay, each other. So when I'm looking at it, if and only if the parallelogram is a rhombus, if and only if AC bisect angle BCD and angle BAD, and BD bisects angle ABC and angle ADC. Okay, so looking at the diagram, you have to kind of know what are your opposite angles and which ones are congruent. Looking at rectangle. Okay, now I'm looking at my rectangle theorems. Rectangle diagonals theorem. A parallelogram is a rectangle if and only if its diagonals are congruent. So this is kind of what we wrote on the last slide with the diagram. If and only if my diagonals are congruent. Go ahead and look at this example. It says quadrilateral ABC is a rhombus. So we're working with a rhombus. I'm going to go ahead and write my properties at the top because, again, if we write them, we'll hopefully remember them. So looking at my rhombus, there were 3. The first one, all 4 sides are congruent. The second one, your diagonals bisect at a 90-degree angle. They're perpendicular. That's my sign for perpendicular. And then the next one, your opposite angles bisect each other. Okay, so now that I wrote that, hopefully we can use those, and we are going to use those. I'm going to kind of do these ones in different colors so we know what we're looking at. So angle ACD. Angle ACD is right here. Who could tell me what is the measure of angle ACD? Good. This is also 62. Because remember, your diagonals, opposite angles bisect each other. So this is also 62 as well as this. So this answer right here is 62 degrees. Looking at the next one, angle DEC. Angle DEC, so that's right here. What would this angle equal? Christian?
It's a different question. Is there a symbol for rhombuses and
No. No, because they're all, remember, they're quadrilaterals. Parallelogram has its own sign. Yeah, go ahead. 90 degrees. Good. My diagonals bisect at a 90 degree. So these are 90 degrees. All right, looking at the next one. Angle EDC, which is right here. Let me actually get a darker color so we could hopefully see it a little better. Right here. This is EDC. So looking at it, how would I find angle EDC? This one's a little, yeah, go ahead, Matthew.
Subtract 180 from 62. Or 62 from 180.
Okay, but why
No,
62?
62 and 90 subtracted by 180.
No.
Shut up,
All right, I'm not going to lie. That could work. Okay, where is he getting that information from? Pay attention. Remember, we've dealt with triangles. This is a triangle. However, that will work. I'm not going to say it's not going to work. It is a right triangle. That would work. But that's not the way that I see it. But you could see it a different way. That's fine. So, Sebastian, go ahead and do that. And then let's see if we get the same answer. Bryce, did you have a different way?
No, I did it.
You did it his way. Did someone else do it a different way? Well, whoever came up with something did it that way. How I would have done it, okay, is we know that it cuts consecutive angles. What do we know about consecutive angles? They're supplementary. So when I'm looking at this, I know I have this entire angle, right? If this is 62, you were kind of on the right track. This is also 62, so what should I do to these to get this entire angle? I'm going to add them. So how I would have done it is I would have solved it as 62 plus 62, or 62 times 2. And because I know that entire angle is 124, what do you think I should do next? Good. I'm going to subtract it from 180. 180 minus 124 is going to give me 56. So I know that this entire angle is going to equal 56. But do I want the entire angle? I only want half of it. So now what should I do? 56 divided by 2, what would that give me? 28. 28. So then I know that this is going to be 28. However, Sebastian, the way that you solved it, did you also get 28?
Oh, I was solving it your way.
Okay, but Bryce, it worked? It still works. Look at it. If I have 28, 62, and 90, if I add them, 90 plus 28 plus 62. If I add these two, that's also going to give me 90. And 90 plus 90 is going to give me 180. So that does work. Yes. I like that you saw that. This is still a triangle. Okay, these are all the same triangles. So that can work if you're specifically looking for this. That can totally work. Okay, so there are options depending on how you see something. All right, let's go ahead and go to the next one. Let's look at this one. What other color have we not used? We'll do orange. All right, looking at the next one, A, B, C. We kind of have that answer. I kind of answered it from the previous question. But looking at it, well, what would my answer be for A, B, C? Good, this entire thing is 56. So do we see that there's multiple ways you can solve these?
Yeah.
Okay, so just understand that there's other ways. All right, looking at this one. Next one is a rectangle. So again, I'm going to write my properties for a rectangle at the top. So we know the properties. There are two that I'm going to write here. The first one is your 4 angles are congruent. Okay. The second one is that my diagonals are also congruent. Okay, so here's a rectangle. We all know what a rectangle looks like. It has congruent sides, opposite sides that are congruent, angles that are congruent, and your diagonals that are congruent. And let's go ahead and answer some of these. Looking at the first one, they want us to find the measure of PON. PON, which is right here. Who could tell me what would this measure of this entire angle be? 90 degrees. Your 4 angles are congruent. If I have 4 angles that are congruent, they all have to equal 90. Okay, so looking at this is 90 degrees. This is 90 degrees. This one is 90 degrees. And this one is also 90 degrees. Looking at the second one, what are they asking me for? They're asking me for the measure of PMO. PMO is right here. How would I find the measure of PMO?
90 minus 29.
Good. 90 minus 29. So if I'm solving 90 minus 29, I'm going to get 61 degrees. And then looking at the next one, I have a segment PL. If my diagonals are congruent,
12.
everything would be 12. All right, and then looking at the last one, number 4, I have MO.
24.
So looking at MO, I'm going to have 12 plus 12 is going to give me 24. All right, looking at the last example, quadrilateral is a square. I don't think I need to write the properties for my squares because I feel like we should know them. Squares are pretty easy. Let me just go ahead and I'm going to draw them on here because just so we know, all of my sides are congruent. All of my angles are congruent. All of my diagonals are congruent. And they bisect at a 90-degree angle. So all right angles everywhere. So now that we know that, answering 2 questions, part A and part B. Looking at A, it says ME equals 7x minus 3, and MO is 6x, find x. How would I solve for x? Charlotte? Good. Set them equal to each other. I have 7x minus 3 equals 6x. Subtract 7x from both sides. I'm going to get negative 3 equals negative x. Divide by negative 1. And x equals 3, and I'm done with this question. Looking at B. It says, if MT is 4x and TE is 3x plus 2, find OE. How would I find OE? Keep in mind they're not asking for x. They're asking for OE, but there's something I have to do before that, Christian.
Using the rectangle that is here on their common root. So to set them equal to each other.
So I'm still setting them equal to each other. I have 4x equals 3x plus 2. I'm still going to have to go ahead and solve for x. Subtract 3 from both sides. X is going to equal 2. Now what do I have to do? I found x. They're not asking me for x. They're asking me for OE. What would I do next? Good. Plug it back into, do I have to plug it into both of them? No, because they're all the same. Which one would you rather plug it into? Which one's the easiest one? MT. So plugging it in, I'm going to have 4 times 2, which is 8. So if MT is 8, all of my diagonal segments are going to be 8. Okay? They're congruent. So what is the measure of OE?
16.
16. I'm going to have 8 plus 8 equals 16, so I know OE equals 16.